Welcome to the next session of Strength of Materials. In this session, I am going to solve question 3 on Macaulay's method. A beam of uniform section is 10 meter long and is simply supported at the ends. It carries concentrated loads of 100 kN and 80 kN at a distance of 2 meter and 5 meter respectively from the left end. Calculate the deflection under each load. Find also maximum deflection. Take moment of inertia as 18 into 10 raised to 8 mm raised to 4 and Young's modulus is 200 kN per mm square. So this is my beam given. At A and B there is a hinge and roller respectively. At C and D you can see there is vertical load of 100 and 80 kN respectively, and the distances are also given. So the first thing that I am going to do is I am going to draw the FBD. At point A there is a reaction VA. At B there will be a reaction VB. C and D will remain same. And these distances are 2 meter, 3 meter and 5 meter. Now this is the FBD which will be useful for calculating VA and VB. Now in the question it is asked to calculate the deflection under each load. So there is load at C and D, so I'll have to calculate YC, YD, which is the deflection. The other question is find also maximum deflection. So I need to calculate that on this beam where is the point at which I am going to obtain my maximum deflection. So this numerical is a little different from the previous two. We will draw the slider diagram now. So I'll draw the beam again. I'll draw the slider at the last section. This is my XX, which will be at a distance X from end A. This is point C, at which there is a load of 100 kN. At D, there will be a load of 80 kN in the downward direction. Now point C will be at a distance of X minus 3 from the slider, and D will be at a distance of X minus 5. So this is my diagram which will be required for solving using Macaulay's method. Now I will start with condition of equilibrium like in the previous two numericals. Summation of force in y direction is 0. Any force going upward will be considered positive. From the FBD I can see VA is going upward, VB is also going upward. I have 180 going downward, so obviously they will be on the other end. I'll mark this as equation 1. Now this is very self-explanatory, so I'm not writing everything. Next I have summation of moment about A is equal to 0. I'm taking about A, so 100 into 2. Now clockwise will be considered positive, so I'll have therefore 100 into 2, and I have this 80 into 5 which is again clockwise, and I'll have VB in the opposite direction into 10 is equal to 0. From this equation I can easily get the value of VB as 60 kN. When I substitute the 60 in equation 1, it is very evident that VA is going to be 120 kN. So these are the values of reaction VA and VB. I'll substitute in this. I have VA as 120 kN and VB as 60 kN. Now using this FBD I can calculate VA and VB. Using this diagram I am going to calculate the deflections using Macaulay's method. I am going to start with the equation mx is equal to EI d square y by dx square. Now this EI d square y by dx square, here I am writing separately, is going to be equal to, I will start by turning all the reactions towards the XX slider. So first we'll have VA into X. The distances need to be marked. Here X is 0, at C X is 2, at D my X is 5, and at B my X is 10. So VA into X will be for the beam portion A to C. So this will be from 0 to 2. Next I have 100 going anti-clockwise, so I have minus 100 into the distance is x minus 3. The domain will be from C to D, so it is from 2 to 5. Next 80 kilonewton is going towards the slider, so minus 80 into x minus 5. The domain is from 5 to 10. So this is my first equation. This equation is called as moment equation. Now I am going to integrate this equation twice to get the slope and deflection equation. So I am writing integrating twice. I have EI dy by dx will be, I'll first write the constant of integration. In the previous problem I have already told you as to why I am going to always write the constant of integration at the start. So the next term becomes VA into x squared by 2 from 0 to 2. Then I have minus 100 into x minus 3 square by 2 from 2 to 5, and this will be 80 into x minus 5 square by 2 from 5 to 10. This is my equation number 2. When I integrate this equation further, I get therefore EI y is equal to C2 plus, this will be integrated as C1x plus VA x cube upon 6 from 0 to 2 minus 100 into x minus 3 square by 2 from 2 to 5, and last is minus 80 into x minus 5 square by 2 from 5 to 10. Now don't write this as VA, you can substitute the value as 120. So I am just marking here 120 everywhere. I just wrote it as VA, you can write it as 120 because you know the value. So these are the three equations I have obtained. Next, from this equation 2 and 3, I will want to calculate the value of C1 and C2 by applying boundary condition. Now if you look at the numerical, at point A and B there are hinge and roller supports respectively. So I am going to have boundary condition at point A and B. When I look at point A, here x is equal to 0, there cannot be any deformation in the y direction, so my y is also equal to 0. At point B, since there is a roller and the distance is x is 10 from the end A, my deflection over here is also 0. So I will write down first applying boundary conditions. First one, at point A, x is 0, y is 0. You need not write at point A, I am just writing over here so that later on when you want to recall, it will be useful for you to just figure out, but it is not required. You can just write down at x equal to 0, y is equal to 0. So when I substitute in this equation, to the left end I am going to get the value as 0 because EI into y is 0 is equal to, right end I have first term as C2, next term x is 0, so I have C1 into 0. I am going to only write till here because I am talking about point A. Only till here I have AC portion of the beam. So I will write down plus 120 into 0. From this I get therefore C2 is equal to 0. Next I am going to apply second boundary condition at point B. At point B my x is 10 meter and y is equal to 0 because this is a roller support. So therefore, when I substitute in this equation, left hand side is 0, C2 is already 0, C1 into 10 plus VA is 120, x cube, x is 10, cube upon 6. Now I am going to write the entire equation because I am going to talk about point B, and if you see 10 meter, the domain also has to be 10. So I am going to write the entire equation. So next is 100, x is 10 minus 3 square by 2. And last term is minus 80 into 10 minus 5 is 5 square by 2. This is not square, this is cube, sorry, by 6. So this will be cube upon 6, cube upon 6. Okay. So here when I substitute, I get the value of C1 as, okay, there is a small correction here. This was x minus 2. So my equations are going to be x minus 2, this is x minus 2, this is also x minus 2, and here I will have x minus 2. So I get the value of C1 as minus 980. Now I'm going to substitute the value of C1 and C2 in equation 2 and 3. I'll rewrite them and I'll get equation 4 and 5 substituting the values. So I'll write down therefore EI dy by dx is equal to minus 980 plus 120 x square by 2 from 0 to 2 minus 100 into x minus 2 square by 2 from 2 to 5. Next I have minus 80 into x minus 5 square by 2 from 5 to 10. This is my equation number 4, and I'll have EIY is equal to minus 980x plus 120x cube upon 6 from 0 to 2 minus 100 into x minus 2 cube upon 6 from 2 to 5 and 80 into x minus 5 cube upon 6 from 5 to 10. So this becomes my equation number 5. This is my slope equation, equation 4, and equation 5 is my deflection equation. Now I am going to calculate the deflection at point C and D as it is asked in the question, and I will be calculating the maximum deflection on the beam. So the first thing that I am going to do is I am going to locate point C. At point C, x is 2 meter. So I'll write down at point C, x is 2 meter. So when I have to calculate the deflection in this equation, I'm going to substitute. Therefore, EI YC is equal to minus 980 into 2 plus 120 into 2 cube upon 6. So I'm going to write only till here because my domain is 2 and also the x value is 2. So when I substitute here, now you just have to see this value of I. It is given as 18 into 10 raised to 8 mm raised to 4. So I can just write here 18 into 10 raised to 8 mm raised to 4, and E is 200 kilonewton mm square. Now I'll just multiply simply and show you. E into I is what I need, flexural rigidity. So this will be 200 into 18 into 10 raised to 8. So this unit will become now kilonewton mm square. Now I need to convert this, so I'll get 200 into 18 into 10 raised to 8. Now I don't need to convert kilonewton because all the load is given in kilonewton here. So I'll just leave it to that. And I want to convert mm square to meter square. So I'll just divide this by 10 raised to 6. So this 10 raised to 6 gets cancelled here. It becomes 10 raised to 2. So I have 18 to the 36 into 10 raised to 4 kilonewton meter square. When I substitute this over here, I get the value of YC as minus 0.005 meter. Next, I am supposed to calculate the value of deflection at point D. When you look at point D, here the value of x is 5. So I'll write down at point D, x is 5 meter. Now for x is 5 meter, I will write the equation till here for deflection. So I'll have therefore EI YD is equal to minus 980 into 5 plus 120 into 5 cube by 6 and minus 100 into 3 cube by. So this will be my equation. When I substitute, I get the value of YD as minus 0.007 meter. So these are the deflections at the point on which load is exerted on the beam. Next, I have to calculate the maximum deflection on the beam. Now there is a technique for calculating the maximum deflection on the beam. If you look at the beam, and you can understand that the deflection will be something like this. When you have a deflection like this, which is a sagging effect, the maximum deflection is bound to lie between the points C to D. Now this is something which I am saying with experience, and also you can say it is assumption for new solvers. So I am going to basically use a trial and error technique over here. I will assume that the maximum deflection is between C to D portion. I will solve and I'll try to get the value of x, the position at which the maximum deflection is exerted. If I get the value between this range of 2 to 5, if you observe here, CD is from 2 to 5, then I will say that my assumption is correct. Say I get the value of x as 3 or 3.5, so it is lying between the zone. So my assumption that the maximum deflection lies between C to D is correct. Suppose if I get the value as 5.2 or 5.3, it means that my assumption that the maximum deflection will be between C to D is not correct. So what I have to do is, in that case, again I have to solve for the entire beam and then calculate the value of x so that I can get a much accurate value. Because the answer may not be 5.2, 5.3 in that case, it could be 5.4 or 5.5 as well. So, or even lesser. So I will assume and I am going to solve. This is completely a trial and error method. There is no hard and fast rule for just telling you that okay, this is the portion where the maximum deflection is going to be. So we will start. Assuming maximum deflection to be between CD portion. Now the domain is going to be 2 and 5. So the value of x will lie between 2 and 5. Now you have to understand that at maximum value of deflection, your slope on the beam is always going to be 0. This is pure mathematics. So now I am going to use my fourth equation which I had obtained. If you remember, this is my fourth equation. In this equation I am going to substitute dy by dx is equal to 0. So I can calculate the value of x at which my y is going to be maximum. So let's substitute. So I am going to substitute in equation 4. So therefore the left hand side is 0 because dy by dx is 0. Right hand side I will have minus 980 plus 120 x square by 2. Now C to D portion ends at this point. So up to this point I am going to use the equation minus 100 x minus 2 square by 2. I am not writing the domain because I just want to calculate the value of x. When you solve this, you will get the value of x as 4.76 meter. When I get the value of x as 4.76, I was correct in my judgment that the value will be between 2 and 5 or on the CD portion. Now since my assumption is correct, I need not think again. My first trial and error method has given me the answer. I will substitute x is equal to 4.76 meter in the fifth equation for calculating y max. So I'll write down, therefore, okay, I'll just write down substituting x is 4.76 meter in equation 5. Now in equation 5 I'll have therefore EI y max is equal to minus 980, x is 4.76. Next I'll have plus 120 into 4.76 whole cube upon 6, and the next term is minus 100 into x is 4.76 minus 2 cube upon 6. I am substituting up to this point. So I'll get the value of y max as minus 0.0079 meter. So this is how you calculate the value of y max. So these are the three answers that I have obtained for the question. I hope you have understood the numerical. If you have any doubts or you want me to solve any numerical, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.